Welcome. Let's take a look at some of the major changes that are being introduced in version 10. We'll start off our demo by choosing a CabinetSense template, and I've created one specially for this demo. In the project scene, you will find two CabinetSense components. The project component, which we will use to define the thicknesses of our material for our demonstration. We'll set our cabinet parts to use 16 millimeters. We can set our doors to be a 19 millimeter frame with a 6 millimeter panel insert. And let's choose a drawer box of 1/2 inch, and we'll use a 1/4 inch for our side, for the bottom of the drawer box. Taking a look at the palette, we define our materials based on 3 factors: the A side of the sheet, the substrate, and the B side. So for the millwork, let me just close this and we'll look at one at a time. So our millwork is defined as alder with a particle board core or substrate and alder on the other side. In this case, CabinetSense assumes that both alders are of the same quality, and it really doesn't matter which side is used to cut or machine from. Taking a look at carcass 2, or carcass 1, we're defining it as being red oak on the A side, and A side is really like the presentation side, the good side of the sheet, with a melamine white on the opposite side. So in this case, it does matter which side we have up or down on the router when we are machining and cutting out the parts. And our drawer is defined as birch with particle board. And again, with birch being the same on both sides, we assume they are of the same quality. But let's assume we're using a Baltic birch plywood. So really we have a good side and we have a not so good side. So we need to differentiate this in CabinetSense so that we know how to process it properly. So the best way to do it is to choose a new image to represent the B side. The easiest way to do that is simply click Good One Side. Click Apply. And CabinetSense has now taken the good side of the sheet and generated a B side from it and has marked it with watermarks so that it's distinguishable as the B side. Let's take a look. We'll bring out our cabinet. Right now we have it defined as using carcass 1 material, which is defined as melamine white, particle board with red oak. And we have good side out. I can simply switch it to good side in, have everything change. I can also change any individual part, and I'll say I want this to be the good side out. So now, even though my cabinet is having all of the parts face inside, the good side face inside, the toe kick or the base is going to face out. Let's take a look at what that Baltic birch looks like. I'll change it to the drawer box material. And here's the markings that CabinetSense has put on the sheet. So this is the B side, and here's our A side. So totally distinguishable. Let's do a test. We're going to change this side so that the good side is out on the right end. And so now what we have is the B side on the right end facing in and the A side facing in on the left side. Let's put a adjustable shelf in. And so now we have some shelf pin holes. On the left end, we need to drill them on the good side of the sheet. And on the right end, we need to drill the holes on the B side of the sheet. Let's go ahead and export this. And let's take a look at what was exported. Here's our export folder and the job that we've just exported. Okay, first thing you're going to notice, we have 2 folders, both with Baltic birch, particle board, and birch. One of them has a GSD and one of them has a GSU, and that stands for good side down, good side up. So if we take a look, our left end, we want to machine on the good side. So the good side must be facing up on the router when we machine the left end. So let's take a look. There's our left end. We go back to our right end. We want to be the good side down so that the bad side or the B side is face up on the router. Good side down, and there's our right end. And so CabinetSense will do that automatically for you and manage all of your exports and placing them in the right folders for you. Let's take a look at what happens if we didn't have that machining of the shelf bin holes. So we'll go ahead and re-export it. So now this is our latest one, and everything is good side up. Left end and right end are the same. So CabinetSense has or knows that there was no machining required on the left and right ends, so it was able to combine them into one. And so what it did, just bring them both in. Was that it flipped one of the ends, so they both look like they're the same. They're oriented identical. But on the left end, the good side now will be facing in. On the right end, this is the good side, and it's going to be facing out. And again, so CabinetSense will look after this automatically for you. Let's take a look at one of the new screens in version 10. And that is how you can handle the job or the materials that are in your job. So this is showing you the materials that are being referenced, the thicknesses of the material, and you now can go in and you can create a default. You can give it a name. So if you don't want it to appear as birch particle board and birch at B, you could say that this is Baltic birch, or perhaps a supplier number. It's up to you as to how you want to use it. And when you make a change to using these tables, you either have to press or click on the check mark, or you have to hit your enter key. If I go ahead and export now, the latest export is using your new name. And also, we had clicked on default. So anytime you use this combination with 16 millimeters as your nominal thickness, you will get this. You will get Baltic birch as the name. And we'll come back and talk about actual thicknesses in a bit. Let's make a couple of changes. In version 10, we now have a nominal thickness for the cabinet. And in fact, every part has nominal thicknesses. So we can change the entire thickness of the cabinet by simply changing the thickness at the cabinet level. We can go in and we can override at each part. So now every part has an override, whereas in version 9 and prior, CabinetSense had override fields. Now every part has a nominal thickness field. Setting it back to 0 puts it back to the parent's thickness. Let's go back to 16 millimeters. Okay, let's introduce the lock. A lot of cabinet builders don't use stretchers when they're building their cabinets, yet CabinetSense requires it for denoting which spaces you want to put a drawer or a door in. So one of the popular ways of handling this is to set it to a very thin thickness. But we don't want this to change anymore, so you can actually put a lock on the thickness. So when you do that, if I come back to here and I change, oops, let's say now I change this to 25 millimeters as my carcass thickness, so I'm going to change all my cabinets. Every one except for that locked part changes. I can also go in and lock the cabinet. So let's say this is a special cabinet and I want it to be 23 millimeters. Bring in another cabinet and it's back to the 16, which is what I have in my project. If I change this to be, let's go 4 millimeters, only this cabinet changes because the left cabinet has been locked. Okay, let's make one more change. Let's make this a 6 millimeter thick back. Let's take a look at our job material list now. So it has grown by a couple. We now have our 6 millimeter material and we have that 0.1 millimeter. So let's go in and say the default, anytime you see the 0.1 millimeter, is going to be do not export it. And let's just say that the 6 millimeter back is really going to be a beige hardboard. Again, if we export it, we now have our beige hardboard and, oops, what's going on here? Oh, we still have 23 millimeters. So let's just go back here. In this case, we've got 23 millimeters, so I could rename it to be something else. Let's just get out of here, go back, change this to 16 millimeters. We can remove the lock if we want because it's back to the standard. And now, if I go ahead and export it, we're back to our Baltic birch 16 millimeters and our beige hardboard 6 millimeters. And you'll notice the 0.1 millimeters is not exported. Let's take a look at the second new screen. And this one allows you to look at the materials in your model and actually find them. So let's go over, let's just shrink this down a little bit for now. So if you can now look at these lists and you can say, oh, well, where is my 6 millimeters being used? I can click on the find icon and it's highlighting it. Here's my 0.1. Look at my rest of my parts. I can look at it from a part perspective. You know, where am I using this back? There it is. So in a large model, you can still zoom in and find out, you know, where things are being used. Not only that, you can change the nominal thicknesses. So if we said, you know what, I'm changing all my cabinets and I just want to change everything. So remember, we could have cabinets at 16 millimeters and cabinets at 23 millimeters, whatever. I can go in and say, I want this to be 15 millimeters. And we've now got it changed to 15. So it's a way of managing your model at a higher level without having to go to individual parts. Now that we've talked about nominal, let's take a look at what actual thickness means. The best way to do this is by showing you an example. So in our cabinet, we are using 16 millimeters. However, let's say that we want to use the finished material to, you know, let's say it's the end of a cabinet run, so we want to use alder on the outside. It's also 16 millimeters. So we have a 16 millimeter birch end and we have a 16 millimeter alder end. However, for some cabinet builders, it's very important that they know exactly what the thickness of their material is so that they get the best fit possible with dados, etc., etc. So what we want to do is to be able to put calipers on the sheets and find out what the actual thickness of the goods that we're really going to use in the shop at the time we build this kitchen. So we'll go back to our job materials, and now we have our alder at 16 millimeters and we have our birch at 16 millimeters. What we're going to do is we're going to say that our birch came in at 0.1595 millimeters and our alder came in at 16.10. All right, now when we click on alder, we look at our right end. The actual thickness is 16.1. If we take a look at our left end, it's 15.95. And in fact, all of our Baltic birch is now 15.95. And if we go ahead and count and measure these, let me increase this by 1. 15.95. So the model has actually been changed to represent the new thicknesses. So our model is precise. All of our machining will be perfect when we export this. And the nice thing is, now you can simply go back. If you said, well, I want to go back to the default, it automatically finds what the new actual thickness is for the nominal thickness of 16 millimeters. So now your designers can design with 16 millimeters. They don't have to worry about what the actual thickness of the material is. That becomes a shop function, so we can separate the two. And again, use it if your shop works this way. If it doesn't, simply use nominal thickness and enter 15.94 as your nominal thickness if that's what you want to do. Totally up to you. 2 ways to use CabinetSense. Okay, the last segment is just showing you what happens when you go from a version 9 model to a version 10. So let me bring up version 9. This is what the materials look like in version 9. Instead of being an A side, B side, it was interior, exterior. So if you wanted to have some cabinets where your exterior was red oak with a white melamine interior, then you would need one definition, the way Carcass 1 is defined. Carcass 2 was exactly the reverse. The interior is red oak and white melamine is the exterior. In version 10, we do away with that by simply saying which is the good side, the A side, which is the B side, and then allowing the cabinet to specify, do I want it inside or outside? Taking a look at this one, we'll bring it in and just see what CabinetSense will do for you. It's coming up and saying, hey, bringing in a model, it's out of date, I'm going to upgrade it for you. And now, first thing it does is it went through your model, it took a look at your material palettes, and it found the materials defined in your palette that have differing materials on each side of the sheet. And what it is asking you to do is simply line up the presentation side on the left. So if we said this B side is actually the presentation side, let's move it to the good side. This one's fine. Let's do this. Click OK. And the materials actually changed in your palette. CabinetSense also went through your model and then aligned the good side in and the good side out as appropriate so that it still remains the same as what your version 9 model was. CabinetSense now has toolbar icons available for most of the CabinetSense menu items. And we've also taken the opportunity to reorganize and group the toolbars in a more logical fashion. Included with this is now a toolbar manager. So here is the toolbar menu, there's a CabinetSense toolbar. These are the icons available. And if you don't want one shown, you can simply just click and move them one way or the other. So we have our one toolbar for CabinetSense, one for a model, component, multi-component, and document, views, etc. You can now have split backs on your cabinets. In the position group, you can click partial back. You can click where you want it referenced and the width of the back. If you want a second back, simply Control Move to create a duplicate. It snaps back into the original place because it still has the same reference points. I'll just change it to from bottom. And now we've got split backs. If I go in and put in a partition, it does the machining on each of the backs. The same with the dado processing. As mentioned, I could change these now to from left, from right, and if I attempted to do the machining again, the partition has no back to go against, so there are no screw holes. If I move it etc. A common problem that occurred in the past was that if you changed the thicknesses of shelves or stretchers and you had doors or drawers attached to that, the actual height of those objects would change as well, which is not necessarily the behavior you really want. So here we have a stretcher that is 16 millimeters. If I change it to 19 millimeters, you'll notice that the height of the drawer box, or the drawer front, which is 165, is going to change. We'll just back that out. There's a new setting now in version 10 where you can basically reference to the midpoint of that shelf or stretcher. And by the way, this is also true for partitions as well. So setting it to the midpoint will now cause CabinetSense to use the same formulas that it uses for drawer box height, or drawer front height and door height. So now if we go back after changing it to the midpoint and change to 19, everything stays the same. So the stretcher changed, but it stayed relative to the midpoint. We've made a lot of improvements to the way our drawer box can be machined. In version 10, you can now machine the drawer box to the drawer front itself. So for example, we are on the right side of the drawer box. I can now attach it to the drawer front. I'll use cabineos. I can put a full dado as well. We'll export this and take a look. There's our right side with our cabineo connectors. Our drawer front, and it has our dado into the drawer front, as well as the dowel holes for the cabineo. In addition to this, we can also handle thicker material for drawer boxes itself. Undermount slides are built to handle a maximum thickness of material. So for example, the material or the slide that I'm using here has a manufacturer's maximum thickness of 16 millimeters. I now can enter that value, and I can say if the material thickness that I'm using is going to be greater than this, I want you to rebate the inside of the drawer side. And so now we've set that, and I'm going to just simply go up and go, I'm going to use 18 millimeter material for the drawer. And we'll go ahead and export this. And let's take a look at our 18 millimeter material. There's our right side. That's our Cabinet connector on the outside of the part. We also had a flip folder. There's our right side. And we've got two dados going on. Here is the recess to accept the bottom of the drawer. And this is the rebate to thin the drawer box side down to the maximum thickness allowed of 16 millimeter. CabinetSense can now determine hinge placement when machining hinges into your doors. Previous to this, you manually had to set the machining patterns. So I've got three examples here. I have a cabinet with full overlay. However, I have a partition which is set to be half overlay. That's the default of CabinetSense. I have my doors simply set to 2 doors. And CabinetSense now, let me just put this, we'll go ahead and machine this, put this into X-ray mode. And so now the placement of the hinge is according to the Bloom manual. We can take measurements. This is 21 millimeters, and the gap to the outside is 1.5 millimeters, so that's 22.5 millimeters. On this side, we're doing basically a half overlay. We haven't told CabinetSense that, but it knows. So if we measure this to the inside, oops, that's to the outside. The inside is 16 millimeters. So it determined that automatically. You can correct it though if you want. Let me go into the door. Let me collapse all of these. And in the hinge, you now have hinge 1, which would be the left door. Hinge 2 is the right door. And they're both set to auto detect so that CabinetSense can determine what hinge placement should be done. But you can manually override it if you so choose. Okay, here's our half overlay. Again, 16 millimeters, just like on the placement on the partition. And then we have our inset. And it's all based on from the corner to here, 24.5. So let's take a look at the database. And this is all that you have to do. There's now new parameters. And what we're saying is the default setting for a full overlay, frameless cabinet, I want you to use that hinge pattern. And that will have the Bloom formula in it for a full overlay. Here is our default setting for half overlay hinge on a frameless cabinet. Use the Bloom half overlay formula. And again, the same with the inset. If none of those are used, so let's say it's a face frame cabinet, right now the default is set to use a fixed position of 22.5 millimeters. We've made a number of improvements to the way that face frame cabinets can be machined as well. first, let's take a look at how we overlap our face frame to our cabinet. We've made an improvement here as well. Previous, you could only set your overlap from the outside. You can now set it from the outside or the inside of the cabinet. So here we've got the left end set at 6 millimeters from the outside. If I uncheck it, it'll go to the inside, and now our 6 millimeters is held here. Also, previous to version 10, hinge clip machining really didn't work all that well. Now we have a tolerance set. So we'll go ahead and machine this, take off the door, and now we're getting our hinge clip even though our end is inside the face frame. Previous to this, CabinetSense would not machine in that situation. And so we have a tolerance set up that you can manipulate if you so choose. The default is 18 millimeters, meaning that I can have a maximum of 18 millimeter spacing from the face frame to the end panel, and I will still do the hinges. Anything above that, and I won't. But you can easily change it by going to the construction group in the project component and changing it right there. In addition, you can now machine the cabinet to the face frame, as well as machining the face frame together. So I'll go into this stretcher, and I'll go to the front, and I'll use a cabinet. Let's use a cabinet on the left side as well, going to the front. And I'll use a cabinet again. And the only reason I'm using cabinet is I've got pattern set up specifically for this demo. Go ahead and machine it, and let's take a look. Go into X-ray. So here's our cabinet for the top with the dowel hole into the face frame. The same for the end panel going into the face frame. And where the face frame is concerned, the top rail going into the left stile, CabinetSense does not do horizontal machining or edge machining, so all that it could do was lay out the holes for the cabinet itself. We've tightened up the rules on construction template processing as well. There was a lot of errors happening because due to thickness changes, etc., where the project would take over and change something that a construction template had done previous. So let's just start off with some general changes. New in version 10, when you check off or choose that you want to use a cabinet as a template cabinet, it will now, let me just open up everything, it will hide all of the attribute fields that you cannot control through a template cabinet. So I've now chosen this one as a template cabinet, and there is the sum of all the attributes I can control. And if I go down, it again only shows you on a part-by-part basis only those fields that can be controlled through the template. Okay, so this template cabinet is for a cabinet type of base. I'm going to move him over to this side. And for this demonstration, I'm going to use thickness fields. So I'm going to say that for a base cabinet, I want everything to be 50 millimeters thick. I'm going to set my project component to be 5 millimeters thick. Okay, well, let's bring out another base cabinet and see what happens. We get the option to say what kind of things do you want to copy from the template cabinet, and I'm going to leave material thicknesses on, meaning if there is a template cabinet, pick up the thicknesses from the cabinet, and it won't pick it up from the project any longer. If I bring in an upper cabinet, you'll notice that its thickness is set to 5 millimeters. The reason being there was no construction template cabinet for an upper cabinet, so it went to the project, and the project had set it to 5 millimeters. If I had, go over here, let's move this one over to the right or to the left. If I set this obviously to a template cabinet as well, I could then say I want it to be, let's say 10 millimeters. Now if I bring in another upper cabinet, it's going to make it 10 millimeters. Okay. A lot of clients have asked for the ability to have simply one construction template cabinet and have it work for everything. And so we've done that. We can now set our construction template cabinet, oops, not that one, sorry. Go to the cabinet, and there's now a common type, and use this specifically for construction templates. So now I've got, oops, let's set it to common, click apply. Okay, so our common template cabinet is 10. Let's bring in a tall cabinet. Again, it asks us what we want to do, and it's going to choose 10 millimeters because even though there's no specific construction template for a tall cabinet, there is a common, and therefore it picks it up here. If I brought out a base cabinet, again, it's going to find the base construction template and use that. So if we were to line this up in order of precedence, the first thing that CabinetSense looks for is a matching construction template cabinet. And if there's no construction template cabinet that matches, then it's going to look for a common. And then finally, if there was no common, it's going to go and choose from the project component.